for exponential equations, remember you've got two options for solving these. You've got working it out by getting the same bases, or you've got using the logs. If it's on the exponential equations page, I'm not going to need you to use logs, so chances are it's going to be nice and easy. Remember, the aim for these is to represent both sides with the same base. Because if you do that, then you can equate the powers. So 2 to the power x is 16, we rewrite as 2 to the power 4. And that obviously gives me x equals 4. So that's a very basic one, but we do need to be able to remember how this works. When you see a fraction, don't get tripped up. This is your fractional indices, or your negative indices again, obviously. So 3 to the power x equals 1 over 3 squared, and 3 squared is 3 to the negative, or 1 over 3 squared can be rewritten. So 3 to the power x is 3 to the power negative 2, so x equals negative 2. Sorry, I'm working across the page here. It's very poor practice. I'll try to zoom in a bit. And then they can get a bit trickier, and I've combined two tricky aspects here. You're going to need to rewrite 49 as a base of 7, and you've got more terms in here. So 7x plus 9 equals, use your index laws. That's 7 squared to 2x. Then you'd expand, so 7x plus 9 equals 7, 2 times 2, 7 to the power of 4x. Now we can equate x plus 9 equals 4x. Subtract x on both sides, because now it's just a nice little equation. 9 equals 3x, so x equals 3. So there's a bunch of increasing complications there. You might just have a nice easy one. You might have to get negative indices involved. You might get an expression up here in the power, and you might have to tweak things a bit to get the same base. Remember, sometimes they might give you something like 25 as a base and 125 as a base, and you'll have to take them both back to a base of 5. That's exercise 3J, so make sure you go back and revise those and make sure that you've done the extension questions. For your logarithms, exercise 10A was really just getting used to the concept. So you do need to be able to convert between index form and log form. So this is, of course, log base 2, 32 gives me 2, 5. Don't get the numbers in the wrong spot. This would be bad. And of course, be able to convert back. Evaluate logs. You can just do that, if you want, as 3 to the power what equals 1 over 9. What would it be?
Negative 2.
Negative 2. If you couldn't do that because your brain was frozen, then change it to index form, and you've got an exponential equation. So 3 to the power what is 1 over 9. And did we just solve that?
Yeah.
Yes, we did. So x is, so that equals negative 2. So you'd solve it. If you can't manage it just logically, 3 to the power what is 1 over 9, then change it to an exponential equation and solve it that way.
Isn't that using exponential equations at all?
Yes.
But you meant to be doing logs?
You are doing logs. They are, as you can see, inherently related.
Yeah.
The strategy is, when you're on the logs page, aim to be using logs unless you can see that the other strategy is going to be better for you. So that was the message that I kept on trying to push on the other one. rational indices, aim to be using rational indices unless you can see that the surds are going to be better for you. But your overall strategy, logs page, use logs. Because this, you don't need the rational indices. You don't need those exponential equations, sorry. Solve logarithmic equations. Now the x can turn up anywhere, and most of the time in this you're just going to be kind of logical. 4 to what power gives me 64? 3. X equals 3. Again, if you can't do it that way, yes, you can change it back to an exponential equation. Here, I've moved the x. So this is 2 to the power 6 is what? Curses, now I've got to count. 64. Thank you. When I'm doing these, honestly, if I've got a minute before I start the test, I'll often write out my powers of 2 and my powers of 3, because I know I'm going to have to keep coming back to them. But when you do start needing powers of 2 or powers of 3, if you want to, jot them down so that you've got them. It's up to you. That's the strategy I use. Yep. So, the log says 2 to this power, 2 to this power gives me that.
Oh, okay.
So it's because of, like, you see what I do. I have to stop and think still. This to that power gives that answer. We do need to be able to use the log laws, and you need to know the log laws. So the strategy for remembering them is to relate them back to the index laws, but you also need to know them. And if I was doing a test, I would write down the log laws at the start, rather than wait until I panicked and needed them. So you see subtraction, you relate that to the index law where you subtract powers. You subtract powers when you divide. So I divide. This will be log 3 of 30 over 10. That's log base 3, 3, and anything with the same base and answer is 1. And of course, what we just did, use logs to solve exponential equations, which is when you've got the nasty questions where you cannot just work out the answer, such as here. Nice, well, easy, can work out the answer. So today we've done that. Use your calculator.